Okay, let's look at this. Show that summation of sine n theta over n over 2 power n is equals to blah blah blah. Okay. Okay, we need to show this equals to this. And we know that to do something, because it involves the Moivre's theorem, so it confirm involves something like this one. So how do I incorporate this into this? So I have this. How about instead of summation sine n theta over 2n, I got summation of n equals to 1 n cos theta plus I sine theta over 2n. Oh wait, at the end here. Okay. This equals to, if I open up the plus, I'll get something like this. Right? And because the I is a constant, I can just take it out. So basically, this summation of sine n theta over 2 power n is actually just the imaginary part of this whole thing, which is the part that has the I, right? So we just need to expand this, okay, into parts of no I, and then get that part, and I'll have my answer, okay? Let me show you. Okay, n equals to 1, n cos n theta plus I sine n theta over 2n. This is equals to just e power I n theta, so I can just write something like this. So n equals to 1, so it's ei theta over 2, ei 2 theta over 2 power 2, ei 3 2 power 3 plus blah blah blah, ei n theta over 2n. Okay, you understand, right? So this is a geometric progression. Its a is ei theta over 2, and its r is also ei theta over 2, because you can see that each time you times by the same ei theta over 2. So this whole thing is equals to a, because you know that GP summation is what? A 1 minus Rn 1 minus R, right? So I get ei theta over 2 times 1 minus ei theta over 2 power n over 1 minus ei theta over 2. Okay, now for the harder part, now it's just you need to just simplify everything. So ei theta over 2, 1 minus ein theta over 2n over 2 minus ei theta over 2. Okay, continue expanding, which is just ei theta 2 power n minus ein theta over 2n over 2 minus ei theta. Okay, you can see that I just remove this and this, and then I move up. Okay, so I get 2n ei theta minus e. This times this is I n plus 1 theta over 2. Because this I'm timing this, I'm bringing it up. 2n plus 1 minus 2 power n ei theta. Okay, this is what I got. Now, for this whole thing, you need to know that you need to know something like this. EI theta equals to cos theta plus I sin theta. EI negative theta equals to cos negative theta plus I sin negative theta. And we know that cos negative theta is actually just equals to cos theta, and sin negative theta is actually equals to negative I sin theta. Okay? So from this I got, if I get EI theta plus E negative I theta, which is equals to this plus this, you can see that these two cancels out and I get 2 cos theta. Or if I get E minus I theta minus E I theta, which is now is this minus this, okay, these two will cancel out and I'll get negative 2I sin theta. Okay, so the whole thing of this summation series is we need to convert this like lot of complex exponentials into patterns of something like these. Okay, same power, and then it's like one is negative, one is positive, one is negative, one is positive, and then it's plus or minus, so I can convert them back into this. Okay, something like that. And how do you do it? One of the ways is we use conjugate. Okay, so it's times, okay, I don't think I shouldn't have multiplied this thing in. I should have left it outside. 2n 2 minus e. Okay, just like that. Okay, so when we multiply conjugate, usually when we do the conjugate stuff, it's like b plus third c. We'll do something like this: b minus third c, b minus third c, right? Which, so it's like one is positive, not one is negative, so we can have b squared minus third c squared. But for this, it's like this. We got a minus e I theta. Okay, if we, let's say it's b, something like this, if we just do something like a plus e I theta over a plus e I theta, the bottom part I'll just get a squared minus e I 2 theta. Like, I cannot do anything with this because I need something like this to convert it back. Okay, I only have a 2 power, which is not what I want. So what I would do is I would say a minus e, but now it's negative the power. So at the bottom right, I'll get a squared minus ae negative I theta minus ae positive I theta, and these two is plus e I theta minus I theta, which is equal to 0. So this whole thing will become 1. Okay, and you can see here a squared minus a e negative I theta plus e I theta plus 1. This is equals to this, right? So I get a squared minus a 2 cos theta plus 1. So you can see I managed to convert it back into trigo. So that's what we want to do. Okay, so we, instead of the normal conjugate of like a minus b and then become a plus b, now it's positive I theta become negative I theta. So 2 minus e negative I theta over 2 minus e negative I theta. Okay, and then I just expand the whole thing. So this times this, 2n plus 1 e I theta, and then blah blah blah, negative 2n. And as you can see, this times this is equals to 0, and e power 0 is 1, so I get 2n. Okay, and then this times this, 2ei n plus 1 theta. This times this is n plus 1 minus 1, so it's plus e I n theta over 2n. Okay, and then just continue expanding, so I got 2 times 2, 4, minus 2e negative I theta minus 2e I theta plus 1. 2n plus 1 e I theta minus 2n minus 2e I n plus 1 theta plus e I n theta over 2n 4 minus 2. You can see this. If I take out the negative 2 out, it's e negative I theta plus e I theta, which is 2 cos theta. Okay, so 2 cos theta plus 1. And then we know that e I theta, I can convert it back to cos theta plus I sin theta and blah blah blah. So I just expand everything. Again, a lot of expansions. Four plus 1, 5. Okay, you can see we're almost there. Our bottom part is already correct. Okay, now remember when I say that we just need the imaginary part for this. We just need the imaginary part of this whole expansion, right? Okay, and the imaginary part is the one that has the I. So instead of continue expanding, I can just take the ones with the I. So for example, I know that I need this. This one have no I, so I don't need. And then I need this, and I need this. So I will get equals to, so this n equals to 1 n sine n theta over 2n is just 2n plus 1 sine theta negative 2 sine n plus 1 theta plus sine n theta over 2n 5 minus 4 cos theta. Here you go. Okay, that's how you do it. So basically you only need you just need to know about something like this, like this equals to this, like the rules, so that you need to find just one sign. You convert to De Moivre's so that you can split it into real part and imaginary part, and then you convert to exponential so that you can work it easier by converting it into a geometric progression, and then you continue converting it, and then you convert back to trigonometries. Separate the ones with the eyes, because the one with the eyes are the imaginary parts, and the one without eyes is the no imaginary part. So if they want me to find cos n theta over 2n, the answer will be 2n plus 1 cos theta minus 2n minus 2 cos n plus 1 theta plus cos n theta over 2n 5 minus 4 cos theta. Basically, I just get the ones without the eyes, okay, and I have my answer. The bottom part is still the same because the bottom part is just a single denominator. Like I can just split it into a lot, so it's the same.